Everybody, this is your instructor for the online computer programming one with Java. I am making this video for chapter 5. So if you go to the modules screen, you will notice that we have the different weeks listed here. In week 8 and week 9, you learn about chapter 4. I posted these the video lecture assignment help links so you can use it to learn about the chapter 4 topics. Similar to this, I'll be doing the chapter 5 video lecture and assignment help in the week 10 and week 11 after I have completed recording this video. The purpose of this custom video for you all is to help you with the chapter 5 quiz and assignment for chapter 5 and also to understand the topics covered in this chapter. So without any further delay, let's move on to the chapter 5. I have this ebook open, which I'll be using as we go through this chapter and covering the different materials. We'll also be using like a Java editor. So you have all have the Eclipse installed because I made you all install the Eclipse, but we can also use, one of these online Java editors. So I will open a couple of these just to, open them and show you because Java is such a simple language that we can use an online editor such as this one to do our entire coding. So we'll use one of these when the time comes, depending on the concept we are learning in this chapter. So this is a continuation of what we learned in the previous chapter, which was also about control statement. A control statement allows us to have deviations, in our code rather than having a structured code going from top to bottom. We can make use of control statements to say if the age is more than 18, do something, otherwise do something else. Those kind of hopping can be accomplished by using the control statements. In this chapter, we will not be doing the selection, which is the if statement we learned last chapter, but instead we'll be learning about the iterations, how we can do some things repeatedly rather than writing the same code so many times. And we can use a control statement, which is meant for iteration. So the topics we'll be learning is the essentials of counter control iteration, how we can use the counter control, a counter, some kind of a counter, use the for and do while iteration statements to execute statements in a program repeatedly, which is at the very center of this chapter. Understand multiple selections using the switch statement, which is similar to the if statement, but it makes it easy when we have multiple things to evaluate. Implement an object-oriented auto policy case study using the string in switch statement, which is an example of switch statement that you will be seeing today. Alter the flow of control with the break and continue program control statement. So two reserve words, one break and another continue, allows us to do something special when we are writing the code. And how we can use a logical operator to form complex conditional expressions in control statements, something like if the age is more than 18 and the person is a resident of Mississippi, and if the person is a student at a certain college, then only do something. So we are using these and a clause while we are speaking to somebody. The same way we can use the and clause to use build what we call the logical operators to build what we call a complex conditional expression. Here's the outline of the chapter. So let's move on to the next page. Um, as I said, this is in continuation of last chapter. We'll be learning about for loop, do while loop, and switch statement. We will be using a bunch of small code segments or small code examples, which you can actually write while you're watching this video so you can build some confidence. Once you get your hands dirty, you will be able to see how they work in action. So essentials of a counter controlled iteration. What are some of the important elements? You need to think about a control variable. A control variable is just a variable which is controlling how many times your loop will run. You need to give it an initial value so that the loop will execute properly rather than having some random value. The increment by which the control variable is modified each time through the loop, which is also called the each iteration of the loop. How much we should increment our control variable And what is the loop continuation condition? Point number 4. So these are the 4 elements when you are thinking about a counter controlled iteration. A counter control means we are telling how many times we want to run it, okay? We are telling the software that we want to do something 10 times, we want to do it something 15 times. So we'll say in our application, we'll ask the user, tell how many times you want to run this project. And the user says 10, then we will use that number 10 and utilize one of the ways of writing iterations, whether it is while loop or for loop, to run that thing 10 times. So here is the code segment which you can actually write, or you can use one of these online Java editors. So let's use this one, and we can say, okay, here's something we have. It's a simple class where I'm just going to remove all this stuff so that it is as clean as one can get. Here is a public class with which is called hello world. So we can leave it as it is, and we have nothing in it here. We have a public static void main. We can just say I'm using a variable called counter, and I am going to make counter equal to 1. So I am giving it a value of 1, and I'm saying run a while loop. So this is an example of while, as you can see here, where we are using a while loop. So we'll say while counter is less than or equal to 10, do something. So we have to use the curly braces to define where the while starts and where the while ends. And what are we doing? We are just going to say, in every line, print the value of counter. This is how we are going to display. So this is your control variable. You have the initial value assigned so that we are not depending upon the value that the Java uh, development kit assigns. We are giving it a value by ourselves. By checking for the counter to be less than equal to 10, we are doing the loop continuation criteria is right here, and we need to increment the counter to be the next value. So we will just say counter plus plus, which would make the counter become 1 more than its previous value. So it starts with 1. Is 1 less than equal to 10? Yes. Then go inside, display the value 1, then make it 2, then go back. Is 2 less than equal to 10? Yes. Then display 2 and go back. So this is how it will run. And given this simple, this is the increment of the control variable in this example. And if we were to run this, we will see the output show up as 1 through 10 in each line, because I'm using println, system.out.println, and here is the output, which I can scroll so you can see it generated number 1 through number 10. What happened after generating 10? It made 10 become 11, and then it went back to line 12, which is 11 less than equal to 10? We will say no, it is not, and therefore it moved out, it jumped to the end, and then it jumped down, it finished the main method, and that's when our project ended. This small code ended. So this is an example. If our counter control variable is 4, then we will have 4, 5, 6, 7, 8, 9, and 10. But if we make it to be less than 6 or less than equal to 6, and when we run it, we will see 4, 5, and 6 in this right hand side, where this online Java editor is displaying the information generated by this code that we have written. So this is the example of a while loop in terms of the different parameters that you need to be aware of listed here, 1, 2, 3, 4. The textbook has a slightly different example, but it's in the same lines as I have shown you all and explained to you. Let's go to the next page. One thing I would like to mention in the previous page is when we are using the loop continuation criteria, and when you are dealing with integers, we should attempt to use integers rather than fractional values. Let's not use double, because that can cause problems. Integer are whole numbers, 1, 2, 3, 4, 5. So integers allow you to have a superior control on your iterations. The for iteration is similar to the while, but it has a slightly different structure. Once you have comprehended the structure of how to write a for loop, you can do very easily. It might look a little bit daunting, but a lot of things that we are doing in a while loop are actually done pretty easily in a for loop. But before we do this, let's go back to our online editor and think about it. If we do not write this line, if I put double slashes in front of it so that this becomes a code, this becomes a comment, please excuse me, then what will happen? The counter starts with 4. Is 4 less than 6? Yes, it will generate the output number 4, and it will not change the value of counter. It will go back again. Is what's the value of counter? Still 4. Is 4 less than equal to 6? Yes, it will generate 4. It will keep on doing until forever, which would run, or your computer will run out of memory. This is called an infinite loop. So we have to make sure that we declare our control variable, we initialize it, we write our condition properly, and we not forget to increment it. We have to make sure we do all this. If we say while the value is less than or equal to uh, you know -1, then it will never run because I made a mistake in my loop continuation criteria. It's not that this is not a valid example. It might be valid in some other situations, but in this example we are basically never going to run see the system.out.println and execute because 4 is not less than or equal to -1. It is more, and therefore it will never run. So these are some of the things you need to keep in mind. Now, how do we write the for loop? So let's just erase everything. Let's just say, okay, we will write the for loop. The for loop has 3 portions. One is the initialization. So we will write counter equal to 1. You have to use a semicolon, and then you have to say what's your loop continuation criteria, which is the second parameter. Then you put a semicolon, and then you write the third parameter, which is how do you want to increment. After that, you will put your curly braces to define where your for loop runs starts and where it ends. Then you have your system.out.println or any logic that you would like to implement for that counter, and it will run. So here we are consolidating some of the things that we did in the while loop. So here we have a counter variable declared right in the for loop. We are checking our loop continuation, and we have the counter plus plus. When we run it, we should not be surprised to see that this generates 1 through 10 right here. I have to scroll down to show you the numbers which are not visible. And here we have an example of a for loop. The 3 parameters that are within the parentheses, all 3 of them are optional. We can just say int counter is equal to 1, and we can totally take it out. It's not that we have to use it. We can just start with open parenthesis, put a semicolon, and run this. Let's just make it 5 so that you all can see the output in the bottom entirely rather than me having to scroll down. It will generate the exact same output as before, but only through 1 to 5. You can also totally take it out and remove it, the third parameter. But if you remove it and if you don't increment it, the counter starts with 1 and it will never change. It will remain 1, and therefore what you will see here is 1 1 1 1 1 1 1 forever. The browser will crash in my example, in my case here, because I'm running it in a browser. But how do we solve this? Well, we can solve it like this. We can increment the value of counter inside the for loop, and it will accomplish the exact same job that was done before, but it is not so clean to understand. We can also pretty much remove this center condition. If we remove it, then this would never end. It would, because we don't have a condition that we are checking. So this is a classic example of an infinite for loop where you're just running a for loop where you are not doing any checking, and resulting into an infinite for loop. But here is another example which is clean and clear, similar to what we did in the beginning. Some of the concepts that I mentioned are stated here. Please read through it so that you can further enhance your knowledge on the topics we are covering in this chapter. So here is the for keyword, which is reserve word. So we have to use it. We can declare a control variable as the first parameter, or we can have it in the above. The second is the loop continuation, and the third is the increment. If we were to write this code and for some reason we let's just say we have everything properly done, but if we just don't write anything and put a semicolon, what's going to happen is, or this is the for loop, it ends right there, therefore it will not have any body to it, which is not a good thing. You should not write like that, because you are having a proper code. But if you are writing your for loop and you have everything done properly, I'm like, sir, I've done everything, why is it not working? Because hey, guess what, by putting this extra semicolon, you pretty much ended your for loop. That means your for loop has nice condition and continuation criteria and the increment, but what does it do? It does nothing, because you just added a semicolon in the end. So by removing the semicolon, now you have a properly structured for loop, which would run nice and well, generating 1 through 5. Here's the same topics that I just mentioned. Whatever you can accomplish with a for loop, you can accomplish with a while loop, and vice versa. So you saw me do that in this video as we were going through it. Scope for a for statement control variable. In this example, the word counter, which is a variable of type integer, it will only live as long as the for loop is alive. After line 15, if I try to write counter plus plus with a semicolon, I'm going to get an error, because that counter does not exist. It has no meaning. It says counter plus plus cannot find symbol variable counter, and it's having a problem right there, because this counter which we declared, it is given the life when the for loop starts, and when the for loop ends, eventually it has no meaning. That means the software is unable to find a variable by the name counter. However, if we were to move this segment out of here and move it down up there with a semicolon, then whatever I have written will work like a charm, because now the counter variable is moved out of the for loop and it has its life starting on line 9. It will continue on until this method ends. The method ends right here. So the public static void main will allow us to use this counter right here. Kindly keep that in mind so that you understand the scope significance for variables. Expressions in a for statements header are optional. Like I described to you, all 3 segments are optional in a for loop. However, it is usually not done like that. You keep the 3 things together so that you have a clean and clear code which is easy to understand. You can also write expressions such as the following. You're saying start my for loop, create a variable j, give it a value of another variable x, and then have a condition, and then the increment criteria. This is equivalent to writing more cleaner code, as you can see here. But in some cases, you may not be able to write it like this. You may be relying upon other variables to define when you're how you want to increment the loop, how you want to determine the times it will run, and so on. In this example, we are saying, okay, we are having this. Let's just go back to our most simple example where we are having a for loop with 1 through 5, and generating the output. Hey, guess what? We can say I want to start from 5 and go until the value is more than or equal to 5, and every time decrease the value by 1, and therefore I'm going to have an output which is 10, 9, 8, 7, 6, and 5. I shall remove this extra line which we were using in our last example, and when we run it we will have 10, 9, 8, 7, 6, and 5. What did we accomplish? We are running it backwards by checking for the condition for the counter variable to be greater than or equal to 5, and therefore we have a backwards generating output. Something to think about. Using a for statements control variable in the statement body, we are all along doing that. We have a control variable counter, and we are using that control variable to display the output. What we can also do is we can say, all right, I don't want to do this, but I want to go until it's more than 0, and every time I run it, I want to make counter become counter -2. I want to generate even numbers. So rather than generating odd numbers in my output, I want to generate just 10, then make it 8, then make it 6 and 4 and 2 and 0. So this is a way of generating only the even numbers. What if we wanted to generate the odd numbers? Well, we need to start with an odd number and then decrement it by 2. So we can say 11, 9, 8, 7, 6, sorry, 11, 9, 7, 5, 3, 2, and 1. This is how a for loop is represented. You have your int counter initial control variable. This is the beginning of the for loop. This is the end of the for loop. You display the counter variable as we are doing, then we increment it, and then we go back and run the for loop however many times, and then we have the end of our code. Examples using the for statement. Here are some of the examples. They are incrementing it by 1. Here we are decrementing it by 1. Here we are incrementing it by 7. So we are going to vary the control variable from 7 to 77 in increments of 7, which is shown right here. We are starting from 20, going to 2, and decrementing it by 2 every time. Here we have another example where we are varying the control variable by 3. So it will generate 2, 5, 8, 11, and so on, because the last portion is what we are learning here for the different combinations that can be utilized. Here we are decrementing it by 11, so we'll have 99, 88, 77, 66, and so on. Here is the example where we are summing the even integers from 2 to 20. So let's just try doing that. We'll just say I have a variable called total, and it's going to be 0 so that it doesn't have any garbage value, and we are going to run a loop which starts with let's just say 1, and it will, what's the values here, from 2 to 20. So we'll start with 2 and keep it going until the value is less than or equal to 20, and every time you run it, we want to make it counter plus equal to 2. So we want to increment it by 2. We are not going to display the value. We are just going to say all I would like to do is make the total become plus equal to counter. So we are just summing up the values and dumping it, accumulating them in the counter, in the total, which is starting with 0. So start with 2, then we hop by 2, so 2, 4, 6, 8, and so on. After we have executed our for loop, we are just going to say system.out.println, and we can display the total. Total is, and we can use the plus sign to display the total variable, and it will just display one line, which will be the total of numbers, even numbers from 2 to 20. Let's just say if we want to only run it until 6. So we will add 2 plus 4 plus 6 and we expect the output to be 12, which is something we can do easily in our mind, in the math in the mind, and we can see the output is coming correctly. This is exactly what they're doing here, and with the previous value which we were getting is also 110, and that's what they are doing here. um, Another example that they are utilizing here is compound interest calculation. Compound interest is a very, very important topic in accounting and in general uh, for investment purposes as compared to simple interest. It's more of a mathematical thing, more of an accounting thing, but it's one of the most important concept that everybody should know about and learn the power of compound interest. If you haven't Googled, try Google power of compound interest and you will see some fantastic video and some websites out there. So here is the code that's been written here. I would like to mention that they are depositing $1,000. They are saying the rate of return that they'll get is 5%. The variables are double. Why are we using double and not integer? Because the output could be fraction. Therefore, we want to capture the fractional portion. We are running the loop for 10 years, imagining that if we keep the money for 10 years, how much my initial 1,000 will be after the years progress. And we are utilizing the math.pow. So math is a class and pow is a static method within the math class provided by Java. It allows us to apply the formula, which is the formula for compound interest. And we are just using the compound interest. I don't want students to worry about what's happening here. This is just a simple mathematics which we are using to display the output. And here's how the output will be displayed for the different years. And you can see immediately after first year you will get $50. Then next year it's not going to be another $50 but $102. If it's simple interest, then you will get 50, 50, 50, 50 for each year. However, you can see that we are getting the money on top of the previous compound interest value. And rather than getting 1500, you got $128.89 extra by virtue of the power of compound interest. Here's a little bit more information given to you on the printf function, which is used here. Why are we using %4d percent and 20.2 f percent n? This is just the formatting. I want you to study this so that you understand. Similarly, the static method pow, which is a short form for power, in the math class provided by Microsoft, provided by Java, for all the developers in the world. Since I teach Visual Basic and other programming languages, I may confuse between Java and Microsoft. That's why I used the word Microsoft in my video a moment ago. Uh, the point I was trying to make earlier about the floating point, we are using 20 because we wanted to allocate 20 position width, a width of 20 positions so that we can display all the information properly. That is why we are doing that 20. When we are using the double variable, which allows us to capture the information in as a fraction, what may happen is the um, rounding of information can cause some mathematical errors, which is okay for simple project, but when you're dealing in money or monetary concept, you may want to also use what's called java.math.bigdecimal and also the new Java Money APIs, which allows us to make sure that the information is not rounded abruptly. As you can see in this example here, if you and I are doing this addition on a piece of paper, we will get an entirely different output than what Java will generate because of the rounding of how the numbers are done by Java internally. So keep that in mind for your future complex projects as you may be working on. What's a do while statement? A do while statement is similar to the while statement. However, in a do while statement, the code, as in general, let me say that code in general runs from top to bottom, left to right. The code will come and run on from top to bottom. It will come across do. Do is just a boundary for the while statement. There is no logic being done. There is no loop continuation criteria written. It's just saying, hey, do this. The line 9 will run regardless, line 10 will run regardless, and on line 11 the while condition written in the bottom, it will determine whether the code will go back to number 8 line or it will just go forward. So the loop continuation criteria is mentioned in the bottom as opposed to on the top. This is just a syntax variation of the while loop that you have learned before, but there is a subtle difference which I just mentioned. One difference: in the do while loop, the code is guaranteed to run at least once. The code in the do while loop is guaranteed to run at least once because the loop continuation criteria is checked after the loop has run one time, and that determines whether it runs again or just skips over. This is how a UML diagram will be represented for the do while activity or iteration statement. The condition of whether to run is done in the bottom, and the code might go top and run again, or it might just end, as you can see in this figure here. What is a switch statement? A switch statement is, perhaps in my professional experience, what I have seen, a switch statement is a cleaner way of writing if else statements. When you have a lot of things to check against, you utilize the switch statement. In this project, we are going to count the number of students who got A grade and B grade and C, D, and F grade. The code runs, and as I have said to you, if you get your hands dirty, you will learn and you will see even small mistakes can cause big consequences when it comes to programming. Companies can lose money, companies can lose reputation if their code fails, and that code can fail by a minor mistake caused by a developer. That is in the grand scheme of things, but for you, when you see mere 40 lines or 50 lines of code, you can actually write it in Eclipse and get a first-hand impression of how it's actually done. So if you have small mistakes or your code doesn't work, identify where you may have made a logical or a syntax error, because that's how you will get better. In this example, the code will continue to ask the user to enter a grade as a number unless and until user presses Control Z on a Windows computer or Control D on a Mac, Unix, or Linux computer. So that's the way to terminate. The while loop is checking does the input has anything in next, or the user has pressed the special characters Control Z or Control D on the respective operating system. Once the value has been determined, then the value is stored into an integer variable and the grade is added up to a total. Then the grade, which is, let's say you scored 99. 99 divided by 10 will be 9 because grade is an integer variable. And if the case is 9, that is, if the value is 9 or the value is 10, then increase the A grade counter by 1 and break it. What's break? That means this switch statement will end and the while loop will go back again. This is how a switch case statement works. This switch case statement from line number 30 until the line number 47 is actually enclosed rather in the while loop, which starts from line 24 right here and it goes until the line 48 down below. You can see how the code is clearly indented over here. Excuse me for this coloring, which is not working as I expected. In any case, this is the switch statement. You're saying if the value is 9 or 10, then increment it by the A counter and break it. Break means do not go forward. However, if the value is something like 8, then increase the B counter and break the switch statement. Similarly, for 7's C, 6 is the D grade, otherwise F grade. What I mean by otherwise, I am utilizing the special word called default, which allows the switch statement to run at least one of the criterias if none of the criterias are met. Therefore, if the score that student received in this case is not in 90s or 100s or 80s or 70s or 60s, then that means he or she has received a lower grade, and therefore the F counter will be incremented and the break statement is added. Even though this is the last line, a break statement is added so that it gracefully exits. And finally, the output of the information is displayed in a tabular manner. If you were to run this, it would appear, you may see enter numbers like this, and you may see that here's the total grade, the class average, and the number of students who received each grade A4, B, and so on and so forth. This is just an explanation of what I am verbally mentioned and how it is done. It's a good idea to read through this so that you are getting the proper information and comprehending the topics covered in this chapter. This is the UML, Unified Modeling Language Activity Diagram for a switch statement. Allows us to take a value and check if it is a particular value, then do something and break it. If not, check if it's another value, then do something and break it. If not, is it another value? So we can do n number of such things that we can do on either a integer variable, which is the case here. The switch statement that we are using is based upon grade divided by 10. Since grade is an integer variable, when we divide it by 10, we will get an integer variable. We can also write a case statement on a string variable, which is totally fine. We can use it even on special characters. We can declare a bunch of constants and utilize those in the case statements. Now, the syntax is something you have to comprehend and perhaps remember. Here is the example of an auto policy where the class will have a bunch of get methods and set methods for the account number, for the make and model, and the state in which the car is purchased. The idea here is that if the car is purchased in Connecticut, Maine, Massachusetts, New Hampshire, New Jersey, or New York, or one of these states, then these are called no fault auto insurance states. I apologize. The no fault auto insurance are applicable for Massachusetts, New Jersey, New York, and Pennsylvania. So let's take a look at it. We have a class called auto policy. It has three class level variables. It has a constructor which sets the account number, make and model, and the state. It has a set method for account number, get method for account number, and similarly for the other two variables. But it also has a method called public boolean is no fault state. It's checking whether this particular class object is in a no fault state or not. How are we doing that? We have a boolean variable which we are going to return from this particular method, and we are saying, hey, let's get the state. And if the state which we received, let's evaluate using a bunch of case statements. So if it is MA or NJ or NY or PA, then no fault state is true. and break it. If it's none of those four, then no false state is false and break it and return the no false value in the Boolean variable as you can see here. So this method is going to return whether a true or false depending on the state for that particular auto policy object. We can write a test class, which is we are declaring a bunch of creating a bunch of instances for the auto policy class as you can see here, and then we are just saying, hey, policy in no fault state uh, uh, for policy 1 and policy 2. What do we do? Here's policy in no fault state. We supply that and we are calling the policy dot is no fault state the value, and state New Jersey is a no fault state. State ME is not a no fault state. So it's going to display the output using the short form for the if statement we learned in the last chapter, which is chapter number 4. And you may remember how we can shrunk the if statement and display something when it is true or something else when it is not true or false. Some of the very excellent examples. These are simple examples that any beginning level developer can write and easily comprehend the topics firsthand. Let's talk briefly about break statement and continue statement. So if you have a for loop such as the following, and we are using a if statement inside the for loop, what we can do is we can say if the for length from 1 until 10, but when it is 5, break it. What do you mean break it? That means do not execute the remaining lines. So line number 10 and 12 will not run when the count is 5 because it will just immediately terminate it. Is it going to break entirely? No, 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 no. It'll go back again and it'll go to 6. If count is equal to 5, then break it. But 6 is not equal to 5, so it will continue on and print it. Guess what will happen? It will print 1, 2, 3, and 4. Why? Because after the 4, the 5 came and it broke the for loop. And that's why we'll only have the 1, 2, 3, and 4. What about continue? Continue is kind of opposite of the for loop. So in case of continue, what will happen is, here's the continue. We'll have the for loop here, which will make it in yellow color. And then we have the if count equal to 5, then continue. What's going to happen when the count is 5? It'll continue. That means it'll just jump and hop back again. And what's going to happen? We are displaying the number every time with a couple of spaces after that. So we'll have 1, 2, 3, 4, no 5 because we didn't even allow the line 10 to run. We said continue. And therefore, it moved up again and continued on with 6, 7, 8, 9, and 10. Break and continue are quite useful operators or concepts that you can use. It comes very handy. You may realize at this time, do I have to use continue and break often? In my experience, continue is quite important because, and so is break. I should say that honestly. In a lot of business logic cases that you will be implementing in a professional organization. Logical operators, let's talk about those. So logical operators allow us to build a complex condition. The word and that we use in our English language for describing some of our thoughts or complex thoughts is represented with a double ampersand sign. The OR is represented with double pipe sign, which is going to come down below, as you can see here. So if you consider, if gender is equal to female and age is greater than equal to 65, then increment the counter for senior female. We are saying when this and this condition is met, then only do this. Rather than using two if statements, we have used just one if statement to combine both the things together so we can easily check and keep our code simple. Only when both the conditions are true, that means only when gender is female and age is equal to 65, that we will go inside this if statement and run this counter to become more than one. Why? Because we are using and. If any of the two conditions are not true, the if statement will not run. And this is what we call a truth table. If expression 1 is false and expression 2 is false, then the output will be false. That means it will not run and go inside that if statement. If the first is false, second is true, still it will not go. In order for a and to work, you have to have both the things true. Uh, an example, in just simple life. If I want to go out and eat in a restaurant, I need, let's just say, two things. I need money and I need to have a car. If I have money, but if I don't have a way to go there, I can't go and eat in a restaurant. I can't dine in a restaurant. Similarly, if I have a car, but if I don't have money, I cannot go and dine in a restaurant. So both the conditions have to be true in order for me to go. On the contrary, the or is if one or the other is true, then go and run this. If the semester average is more than or equal to 90, or the final exam is more than or equal to 90, then the student gets a A grade in this example. So if one is true or another is true or both are true, then the output for a or statement is true. If both are false, then the or statement is false. Um, Short circuit evaluation of a complex condition. Uh, the and or that we learned, what it does is, in case of and, if the first condition is false, then it just skips the second condition. It does not even bother, because for an and, both the conditions should be true. In case of or, if the first condition is true, then second condition is not even checked, because if first is true, in case of an or, the whole condition, the compound condition is true. This is called short circuit evaluation. We have the Boolean logical operator and or, which are just short one letters for what we have seen. In case of Boolean, the other conditions are always evaluated. Even if the gender is 1, it will still go and in this example, if gender is not 1, it will still go and check this before finishing this line, which may seem like an overburden. Like, why would you like to do that? If first is already known, not true, then we know that it's not going to happen. Like I was talking to you about my going to restaurant example. In some business situations, in some specification implementation, you may use the Boolean logical and Boolean logical inclusive or, where you need to evaluate both the condition regardless. Boolean logical exclusive or, which is a very unique one. What it does is it only returns true if one or the other is true, not both. So if both are false, it's obviously false. If one is false and other is true, it is true. If both are true, then it is false. So this is where you have the exclusivity. You don't want somebody to have both the conditions true, but only one. In that case, you will use this caret symbol, which is shown as a upside down V, and you will use that for Boolean logical exclusive OR. There is a negation operator which negates. If the output is true, it makes it false. If the output is false, it makes it true. You have to use a parenthesis so that you are easily able to describe what is that you are checking when you are doing a logical negation operator. There are practical usage of this, but our mind is tuned to thinking positive thoughts, positive ideas. So when you have to look at this code and try to understand this, it's very difficult to comprehend this way. But you can say if the grade is not equal to sentinel value, then do something. It's this and this code are exactly same. It's just that the way we are writing the if logic makes a big difference with easily comprehensible and somewhat challenging to comprehend. I am not saying that there are not practical use of negation. It is there, but uh, please understand, in some cases you can easily write the condition much easier. Here's a good example where they are utilizing all the different and or combinations, the truth table that I mentioned about for the and, logical or, boolean or, the exclusive or, and the negation operator. So go through this, please. Precedence and associative of the operators presented so far. This is the operators that we have learned. Some of them were described in the last chapter, but for and, it goes from left to right. The other ones also go from left to right, except for the short form of conditional statement we learned last chapter, and for these assignment operators. Structured programming summary. So Java control statements are single entry, single exit, which makes your code easy to read as well as easy to uh, easy to read and easy to perhaps more controlled, perhaps I should say, because in previous programming languages where you are using go-to statements, it makes your code so difficult to comprehend, which is no more the case with the current programming languages we use. But what have we learned so far? We have learned the sequence, which is the basic fundamental concept of writing your code. If and if else statement, which is selection, you are doing one or the other thing. Similarly, switch statement, not to say that is not correct. These are the options provided thus far we have learned in Java. And repetitions, which is can be done using a while loop, do while loop, or a for loop. So this is the summary. These are the four rules which are kind of the global rules you can use when you are having difficulty conceptualizing how do I solve a problem. Um, Begin with the simplest activity diagram. Any action state can be replaced by two action states in sequence. Simple. Any action state can be replaced by any control statements, and repeat the rule 2 and 3 as often as you need. So let's say this is the action state. If it can be done in multiple, you will do like this. When you have to apply some selection, you can do like this. And if the selection requires further drilling, you will drill like this. Your code will be able to read in a sequential manner, in a structured way. If you follow the rule, an unstructured activity diagram like the one here cannot be created. You will always have a structured activity diagram. The three forms of control we have learned: sequence, selection, and iteration. Sequence is just write your code. Selection is if statement or switch statement or if else statement. Iteration is for loop, while loop, do while loop. By and large, you can accomplish all the selections with if statement, and while can be used in any situation. So these are like some of the things you can take away. There are some graphical user interface examples to visually draw something using the concept learned in this topic. I am going to leave this for you all to learn. And with this, we are at the wrap up of what we have learned. The assignment for this chapter is to do 5.5, 5.6, 513, and 518. So let's go to the assignment area and we can spend very brief amount of time on those assignment points. Describe the four basic elements of counter control iteration. This is what we started off with when we were coding. So if you were to remember, the very first thing, and I'm just doing undo to go back, but in any case, You should remember the four basic elements, and you can submit it in a Word document. Counter variable, initialize the counter variable, loop continuation criteria, and increment the counter variable. These are the four basic elements. 5.6, compare and contrast the while and for loop. What can we do with while loop? What can we do with for loop? Well, the structure is different. While loop also comes in a flavor like do while, which allows the code to run at least once. While loop requires that the counter increment line is within the while loop, otherwise we'll have a infinite loop. In case of for loop, the counter increment line is in the for statement itself. Although it can be removed, it's optional, but it's in that for loop line itself, not inside the loop. So some of the things you have probably learned as we talked in this video. The 5.13 is a factorial. Factorial, if you just Google for it, you will see factorial, or you can say factorial calculator as well. It's a pretty simple, factorial of 2 is 2 times 1. You just go backwards. Factorial of 3 is 3 times 2, which is 6. You just go backwards from the number. So 5 times 4 times 3 times 2 times 1. That's the 5 factorial. So you have to write a code which will take a positive integer, and it will, pardon me, write an application that calculates the factorial of 1 through 20. Use the type long, because the value for a factorial can grow very fast, very big, and therefore we are not using integer, but we are using long. Display the result in tabular format using system.out.printf. What difficulty might prevent you from calculating the factorial of 100? Well, the factorial of 100 is such a large number that it might not fit in a variable of data type long. That's the problem you will face. But please try to understand. You are going to use a for loop. You will start with 1. You will go until 20, and every time you are doing that, you are and you are going to have a variable called factorial, which you will say initially my factorial is 1 to be safe, and you are saying, hey, I need to calculate the factorial. So the factorial is equal to, or you can use star equal to counter, and you can display the factorial by doing like this. So factorial of counter is something like this. So this is just an example. You may do it totally different, but we are just multiplying. Let's see what we get. Since I'm using an integer, I might run into some problems, and I absolutely have run into some little problems. Let's just see. Expected factorial plus. Let's just make it long so that we have no problem, first of all. And second of all, we are having a little bit of problems with these quotation marks. So probably I am supposed to use single quotation marks rather than double quotation marks. Actually, it might have been the same, but in any case, we shall see if this will also work. Okay. And when we are doing this, I had a small problem elsewhere, and I thought it was my quotation marks which was causing the problem. But in any case, I hope this is good enough. And it should display the output, which it is not. Let's try to use less than equal to. You can see how easy it is to miss a small thing, but this is how your output probably will look like. We are just generating the factorial, and you can see the factorial of 20 is such a mammoth number. So you can imagine factorial of 100 probably will not be able to fit inside the long variable. The last assignment you need to do is 5.18, which is down here, which is modifying the compound interest program to use only the integers to calculate the compound interest. You may treat all the monetary amount as integer numbers of pennies. Now, please read through this. The code is given in the book. Copy and put it into a code of your own. Change the variables to integer and adopt the details mentioned here to complete your project for 5.18 assignment. You can submit it by clicking on this button. You can submit additional files. You can also add text entries to make multiple submissions so that you can submit answer for all four. I'm going to post the link for chapter 5 under week 10 and week 11 shortly after I'm done recording and posting this video. I hope this was helpful, folks, and you got to learn the very fundamental, very important part of Java, which is the selection, sequence, and control statements or iteration. Thank you very much. If you need to reach me, my email, phone number, and other details are on Canvas homepage. Feel free to let me know if I can be of any further assistance to anybody. Thank you.